Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from January 2024 paper theory. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. As I mentioned before, P theory exam is not difficult. You just need basic understanding of measurements. If you have basic understanding of physics, then no more fear of P theory. So watch this video carefully and try to improve your understanding. When you have good understanding, P theory exam is just a piece of cake. And also, if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. Let's study together. Let's improve together. First of all, let me explain you what is meaning of this one. Take measurements perpendicular to the scale using a set square. So you can see in this case, this is our meter rule. So this is meter rule and this one is our set square. So this is set square and you can see this angle between them. This angle is 90 degrees. So first of all, you have to place your set square like this. And then this part, you have to align with the bottom of the mass. So you have to align this one with bottom of the mass. So this one is the mass. I mean this mass we have drawn here. So then you can read from the meter rule. So this is how you can use set square and this is meaning of take measurements perpendicular to the scale using a set square. I hope this helps. If you have still any questions, you can ask me in comments. Third question says a student used a laser and screen to determine the diameter of a hair. The apparatus was arranged as shown in the figure. For part A, identify a health and safety issue caused by using a laser and how this issue may be dealt with. So first of all, we need to understand, if you look at laser directly, light of laser is very intense. So it can damage our eyes. So we should not look at laser directly with naked eyes. Or we can wear dark glasses to protect our eyes. So these 2 points you can write down in your answer. Now let me show you the answer, how you can write down your answer. In the answer you can mention these 2 points. You can say laser light may cause damage to the eyes, so don't look directly into the laser beam, or you can wear dark safety glasses. Part B says the student placed the screen 2 meters from the hair. He switched on the laser. A diffraction pattern was produced on the screen as shown in the figure. The student used a meter rule to determine the distance between adjacent minima. Describe how the student should determine an accurate value for the distance between adjacent minima. We can answer this question using different ways. One possible way is we can draw the line here. So this is the center of minima and next minima we have here, so we can draw another line here. So this is the center of next adjacent minima and the value of distance x between them we can find. Let's say this one is x and we can repeat this one for many adjacent minima and finally we can calculate the average value. So this is one way to do, and the second way is we can find the value of x for 10 adjacent minima and we can divide by 10. So we can also find value of x and that value will be more accurate. So you can write any one of them. I'll be writing the first one in this case. So how we can write down the answer? This is how you can write your answer. You can say measure the distance between center of adjacent minima, repeat for different pairs of adjacent minima and calculate a mean value of measurements. So this is how we can do, and we follow the same way. For example, when we measure time period of simple pendulum, we measure time for at least 5 oscillations or 10 oscillations, and then we divide that time taken by number of oscillations. So let's say this is the time taken for 10 oscillations, we will divide by 10 and we can find the time period of simple pendulum, because this will improve the accuracy and this will minimize the percentage uncertainty. And the same you can also do for this type of questions. Second part says, explain how the student could modify the arrangement of the apparatus to reduce the percentage uncertainty in this value. So first of all, we need to understand how do we calculate percentage uncertainty. Percentage uncertainty, this can be equal to half resolution. So we can say half resolution divided by measurement multiplied by 100. If we're using one instrument, so for the same instrument, half resolution, this one will stay constant if you're using the same instrument. So this value is constant for any instrument, means each instrument has its own half resolution. And this measurement we can change. So we can change this one, but we cannot change half resolution for any instrument. That is fixed value for one kind of instrument. So we can increase the measurement. So if we increase the measurement, it means that percentage uncertainty, this one will go down. So now the question is that how we can increase measurement in this case. So we have already discussed. Imagine that this is representing one dark fringe. Now simply we can say this is representing one minima and this is representing an other minima. So this is another minima. And the distance between these two, we can also mark this distance. Let's say this distance between them, the separation between them, this is equal to x. So if we increase x, so it means that we can minimize percentage uncertainty. So how we can minimize percentage uncertainty? We have to increase x, and in order to increase x, we have to increase the separation between this, means separation between the slit and the screen. So if we increase this distance, let's say this distance is capital D. So if we increase this distance between slit and the screen, value of x will increase. So may we see these minima like this, so the distance will be increased. So this distance will increase. So in this case, we can reduce percentage uncertainty by increasing the distance between slit and screen. So these 2 points you can write down in the answer. This question has 2 marks, so we can write down these 2 points. The first point, you can say increase the distance between the hair and the screen, as this will increase the separation between minima. Means when we increase this, it will increase value of x. Part C says the student repeated the procedure using 3 different lasers. Each laser produced a different wavelength of light. The student calculated the diameter d of the hair using each laser. He recorded the values as shown in the figure, as shown in this table. Determine mean value of d. Very straightforward question, very easy question. So simply we need to calculate the mean value. So simply you can say we need to calculate the mean value of diameter, and different values of diameter are given to us, and the unit of this one is micrometer. So simply we can write on here 76.0 micrometer, we have 84.4 micrometer, plus we have 77.1 micrometers, divided by the number of readings. We have 3 readings. Now if we simplify this one, we will get 79.2 micrometers. So this is our final answer. One thing you have to be careful is, as this data, this one has 3SF, this has 3SF, this has 3SF, means the given data, it has 3SF. So the final answer also should have 3SF. So answer should have, so let me write down number of SF. Let's say we have raw data, so let me write on here. If we have raw data, let's say this has 2SF, then this has 3SF. So how many SF we need to use in the answer? In the answer, you can use 2SF, least number of SF, 2SF. So it's better to use 2SF, or you can use one more than the least. So the least is 2, so you can use also 3SF. Least number of SF in the data means the number of SF in the answer should be equal to least number of SF in raw data or one more. Now let's say we have data that has 2 SF and that has 4 SF. So how many SF we have to use in the final answer? So the least number of SF we have 2. So your final answer can have 2 SF or one more. So it can also have 3 SF. So this is the rule you need to understand. Second part says determine the percentage uncertainty in the mean value of the percentage uncertainty. So in this case you can see we have multiple readings. So it means we have to use half range method. So first of all we will try to find out absolute uncertainty. So absolute uncertainty in data. Absolute uncertainty. So we can write down absolute uncertainty. And this is equal to the half range of given data. So we can say this is equal to half range. So in this case this one is the maximum reading and we can say this is max and this one is minimum reading. So we can write on maximum minus minimum. So this is the range, but we need to calculate half range, so we need to divide by 2. So we will get in this case 4.2 micrometers. And in order to calculate percentage uncertainty in D, we have to use the half range, means the absolute value. So we have to use the half range divided by the mean value. So we have to use the mean value of D multiplied by 100. So half range we have that is equal to 4.2 and the mean value is 79.2 multiplied by 100. So in this case we will get 5.3%. So this is how you need to calculate. So simply we can say percentage uncertainty in mean value of D is 5.3%. But one thing we need to understand, let's say we have more readings. Let's say we have laser 4 and this answer, let's say this is 105.4. So you can see this data is very close to each other, but this value is totally different. So this is anomaly, this is due to error in measurements, you can say this is outlier. So you need to ignore this one when you calculate half range. If one value is totally different, one or two values are totally different than rest of the data, so you can ignore that one when you calculate half range. So this point is very important. Next time they can give you data and they can ask you to calculate half range, so you have to ignore this value. So this is very important point. Part D says in a different experiment the student applied force to stretch the hair. He determined the breaking average stress for hair as 181 megapascals with a percentage uncertainty of 6%. The student suggested that the breaking stress for hair is the same as the breaking stress for copper wire. Deduce whether the suggestion is correct. Breaking stress for copper wire is 210 megapascals. So in order to answer this question, first of all simply we can say for hair breaking stress is equal to 181 plus minus 6%. It means that the actual value of breaking stress, it is between 181 minus 6%, you can say. It also means that 181 multiplied by 0.94 means this value, and the upper limit is 181 plus 6%. It means that 181 multiplied by 1.06. So this is the lower limit and this one is the upper limit. So simply we can calculate this upper limit. If this limit is higher than 210, it means suggestion can be correct. If the upper limit is lower than 210, it means suggestion is not correct. So if you multiply these two, you will get 192 megapascals. As this value is low, so let me write down here as 192 megapascal. this is lower than 210 megapascals, it means not correct. So suggestion is not correct. So simply you can say, so suggestion is not correct. So this is how you can answer. So in the answer you can write down 192 megapascal means the upper limit, you can say here as the upper limit. Upper limit 192 is less than 210 megapascal, so suggestion is not correct. So this is how you can answer. In the answer, for example, you can write down, let me little explain you how you can write down the answer. You can say as upper limit for breaking stress of hair is equal to 192 megapascals, and 192 megapascals is lower than 210 megapascals, so suggestion is not correct. So suggestion is not correct. So this is how you can answer your question, and this question is a typical question, mean this concept is typical. You will see in other papers as well. So you need to understand how to deduce whether the suggestion is correct or not. So in this case it is not correct because this value is not in this range, so it means this is incorrect. Some student, they ask me before, why do I multiply with 1.06? It simply means that 100, let me explain a little about this one. 181 100% plus, it means 86%. So you have to multiply this one with 0.06, and that one will be equal to 192. So this is 6% extra than this value. So you have this value, you have to add 6%, and 6% means that 6 divided by 100. So it means this is equal to 0.06. So this is how you can answer. So this is 0.06. You can also understand from here, for example, we have 181, we have plus 181 multiplied by 0.06. So you can simply take 181 common, so you will have here 1 plus 0.06. It means that you have 181, you have to multiply by 1.06. I hope it will help some of you and it will answer your question, why do we multiply with 1.06? So you can understand this way, you can understand like this. If these videos are helping you, they are helping you to improve your understanding of physics, please like and subscribe, because your encouragement is very important. These videos, they take time and they need energy. So if they're helping you, support your teacher by liking and subscribing, and also share this one with your friends and classmates. So that is kind of support from your side. I hope you will do this. Question 4 says, a student investigated the inverse square law for light using the apparatus shown in the figure. The student used a meter rule to measure the distance d between the filament of the bulb and the sensor on the light meter. The reading on the light meter is the intensity I of the light. Explain how two sources of error can be reduced in this investigation. So first of all, we need to understand this experiment is about light. So any experiment where light is involved means light experiments should be done in a dark room. So this is one thing you can say, experiment should be done in a dark room, because external light, it will affect the results. So this is one thing you can say. The second thing we can say is, in this case, d is this distance, but this is not right. We need to measure distance from the center of this bulb, center of filament. So we have to measure distance from the center of the filament. And with the help of meter rule, we cannot measure distance from the center of the filament. That distance will not be accurate. So how we can measure distance accurately? We can find out. So let me little clean this one. So we can find first of all the diameter. We can find out diameter of this light bulb, and after finding the diameter we can add that radius. So we can say here we can take this point and we can take this point, so we can find the diameter. And after finding diameter we can find the value of the radius. So this one is diameter. We need distance from the center of this filament. So the d new, actually the new value of d, it should be d plus the radius of the bulb. So this is how we can minimize the error. So these are 2 points you need to mention in your answer, and this question has 4 marks if you have mentioned 2 points, and also you have mentioned how to fix them, means 2 sources of error, and how to minimize them. You will get 4 marks. Now let me show you the answer, how you can write the answer. In the answer you can mention it cannot be measured to the center of the filament bulb accurately using meter rule. So measure the diameter of the bulb separately and add the radius to the measurement of d. So that will be our new value of d. The second point is a very common one. You can write down for any light experiment. We can say the background light will affect the readings on the light meter. So do the experiment in a dark room. Part B says the relationship between I and D is given by this equation, where k is a constant. Explain why a graph of I against 1 over d square should be a straight line through the origin. Pretty straightforward question. So simply what we need to do is we need to write down I is equal to k times 1 over d squared. So you can little bit rearrange this one. Now we need to compare this one with straight line equation. We can say y is equal to mx plus c. So we can write on 0 here as well. And so in this case we have on y-axis this is current, on x-axis we will have this one, and the gradient in this case will be equal to k. So simply we can say in this case gradient is equal to k, and k is a constant. So it is given to us k is a constant. So k is a constant. So it means it has to be a straight line with constant gradient, and it has to pass through the origin because y-intercept is equal to 0. So we can say as y-intercept is equal to 0, so it has to pass through origin. So simply you can say pass through origin because y-intercept is equal to 0 and gradient is equal to constant, so it has to be a straight line. So we can say it has to be a straight line with constant gradient. Straight line with constant gradient, or we can say with only one value of gradient, with constant gradient. So this is how you can answer the question. So very common question also. Any equation is given to you, most of the time you simply need to compare with this straight line equation. Second part says the student varied d and recorded corresponding values of I. She recorded the results in the table as shown. Complete the table with corresponding values of 1 over d square. Use the additional column to record your process data, means calculated data. So we have to record here 1 over d square. So first of all we can write down the quantity, and also we need to write down the unit of the quantity. So here we have d, and this d has 3 SF. 3 significant figures. So we also need to use here 3 significant figures. You can see all this data has 3 SF. This also has 3 SF because it has non-zero digit on the left side, and also it has decimal and non-zero digit on the left side of the 0. It means those zeros are significant. So it has 3 SF. So in this column all values should have 3 SF. So how we can calculate 1 over d square? So simply you can say 1 over d square, and value of d is 0.1 1 to 5 square. If you solve this one, we will get 64.03 SF. And so simply you can write on here 64.0, and you can do these steps for rest of the values. Now let me show you the final table. This is how your table should look like. So these are the final values. If you have done this one, you have completed this column and also this heading, you will get 2 marks. And for the third part, we need to plot a graph of I on the y-axis against 1/d on the x-axis on the grid opposite, and this has 5 marks. So the graph is very important. You have to do graph carefully. And for next part, we need to determine the value of k from the graph, and this one has 3 marks. So you can see this one has 10 marks. Means you need to complete the table, you need to draw the graph, and you need to calculate gradient. If you do this, this has 10 marks. So you have to be very careful with this part of the paper, means this question, because this question can improve your grades and can give you higher score in this paper. So try to master this type of question, mean questions about graph. So we will go to the next page and we will sketch the graph, and then we will find the gradient. Now let's try to sketch the graph. In the question, it is given to us that this quantity should be on the y-axis. In the question, it is given to us, and this quantity should be on x-axis. So we need to write down the quantity here. So we can say this is I, and the unit of this one is watt per square meter. And on x-axis, we have quantity that is 1/d square, and the unit of this one is per meter square. So this is first thing you need to do. On y-axis and on x-axis, you need to write down the quantity, and also you need to write down the unit. The next step is we need to choose the scale along x-axis, and also we need to choose scale along y-axis. For x-axis, you can see the maximum value. So how we can choose the scale? Maximum value is 64 minus we have minimum 1.78, and we can divide this one by number of big square. How many big square we have? 1 2 3 4 5 6 7 8, and this difference, so we can divide by 8. So approximately, for example, this one, if I say 70 divided by 8, around I can write down is 10. So around, you have to choose the convenient number. So in this case, 10 is convenient one. So we will be using here. Actually, if we divide this one over, it will be smaller than 10. But we have to choose convenient number so you can sketch graph easily. Now for the y-axis, we can also do the same one. For the y-axis, maximum value, so we can write on the scale. We have maximum value that is 996, minimum value is 18. And we need to divide by number of big squares. So here we have 1 2 3 4 5 6 7 8 9 10 11 12. So we can divide this one by 12. So this is about 1000 roughly, I'm talking about roughly, and this is 12. We can take this one as 10, so we can choose around 100. So this is nice number. So with the help of this one, easily we can sketch the graph. So now we have, this is approximate this value, so you will get the exact value. Then you need to think about a number which is easy to plot the graph based on the given data. So these two numbers we can use to sketch the graph. Now if we have these scales, now let me show you how you can sketch the graph. So this is how you can sketch the graph. So we have on y-axis, we have 100, 200, 300, 400, 500, and so on. And here we have 0, 10, 20, 30, 40, 50, 60, 70. Actually, real graph has 8 boxes. So here you can also write down 80 here. You can write down here 1100 and 1200 on the real graph. This is just sample graph to make it easier for you. So this is just sample, but you have to follow these steps. Now this is our graph. You can see in this case this point is above this line, so this is best fit line. This point is above this line, and this point is little below, and this point is also little below. And if we look at the vertical distance from the line, distance is almost same, so it means this line fit all these points. And this line means your data, when you plot data, means this point and this point, it should cover more than half of the graph paper. So this is very important. Now you can see along y-axis it cover more than half of the graph paper. Along x-axis it also cover more than half of the graph paper. It means this graph is acceptable. Next thing what we need to do is we need to calculate the gradient. In order to calculate the gradient, we can simply draw this triangle. You can take any 2 points on this best fit line, and the distance between points has to be more than half of the length of best fit line. So these 2 points we can take. Now we need to calculate the gradient, so we can calculate simply gradient now. So we can take this point, so this value is about 940, and this y value is 200 divided by x value. X value at this point we can read this is 60, so here we have 60, and x value from here, this is about 13, so this is 13. So if we simplify this, we will get 15.7. Now what is the unit of this one? Unit. So on y-axis we have unit, that is watt per square meter. On x-axis we have unit per square meter, so it means per square meter will be cancelled. We will get 15.7 watts. So this is how you can sketch the graph. I use this sample graph actually, but you can do graph by yourself. You can follow these steps. These are the points you need to understand how to sketch a proper graph. And if you have any questions about graph, you can leave your questions in comments. I will try to answer as soon as possible. And this method every time you can use when you need to find the unit for the gradient, and always write down a unit for the gradient. Part 5 says the student switched off the filament bulb. She recorded the intensity of the background light as 4 watts per square meter. Switched off the filament bulb means when filament bulb is not there, what is the intensity of background light? That is 4 watts per square meter. The student then switched on the filament bulb. She moved the light meter to change D until the reading on the light meter was 8 watts per square meter. Determine the distance between the light meter and the filament bulb. So in this case we have background light intensity, so we can say we have background light intensity. So we can say light intensity, that is 4 watts per square meter. So now we can write down intensity of light bulb. Intensity of light bulb. So intensity of light bulb, that has to be equal to 8 minus 4. So we can say that is also equal to 4 watts per square meter. Now we need to calculate value of D, but in the question it is given to us that intensity is equal to K times 1 over D square. Then K is the gradient. K is equal to gradient, and value of gradient we have already found in the last part, that was equal to 15.7 watts. Now simply we need to plug in values. So if we rearrange this one, we can say D square, this will be equal to K divided by I. K divided by I, so we need to find out value of D, so this will be equal to K divided by I, the root of this one. So value of K we have, that is 15.7, and value of I we have, that is 4, or simply you can say 8 minus 4, and if we solve this one we will get the final answer. So this is up to 3SF 1.98, but as in this case the least number of SF we have is 1 and the maximum is 3, so it's better to write down up to 2 SF. So we can say this is 2.0 meters. So this is our final answer. So this is how you can answer. I hope this paper was helpful, means this video was helpful. Please like and subscribe, and if you have any questions you can leave in the comments, and if you're looking for extra resources you can join Patreon, and also paper and mark scheme you can also find on Patreon. That's all for this video. See you in next video.